Hello everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to continue with the chapter Chemical Kinetics, and we will be starting with the concept of rate of reactions in greater depth. So when we were discussing the rates of reactions in the last lecture, we just defined as to how the rate of reaction can be written, and that was change in the concentration of reactants or products divided by the time taken. That is decrease in concentration of reactants divided by time taken or increase in concentration of products divided by time taken equal to minus delta R upon delta T or equal to delta P upon delta T. So here we will be moving on from this concept to further greater details of the rates of reactions. Before we begin, a piece of information for you. You can use the coupon codes Mission JEE or Mission NEET while you enroll at First Online University for Mission JEE or NEET. Now, what is average rate of reaction? The rate of a chemical reaction in the smallest, appreciably smallest interval of time is called the average rate of reaction. So whenever we're talking about, right, like the reaction has taken place over say a period of 5 minutes, but when I want to talk about the average rate of time, average rate of reaction, then I will be considering the rate in a very small interval of time. 1 mole of the reactant produces 1 mole of the product for any given reaction. If R1 and P1 are the concentrations of reactants and product respectively at time T1, and R2 and P2 are the concentrations of reactants and products respectively at time T2, then the average rate of reaction, that is rate of reaction first of all, is going to be equal to rate of disappearance of R, that is equal to decrease in the concentration of reactant divided by time taken, which is equal to minus delta R upon delta T. That is equal to minus of R2 minus R1 upon T2 minus T1. The negative sign is indicating a decrease in the concentration of the reactants. It can also be expressed in terms of rate of appearance of products, that is equal to increase in the concentration of product divided by the time taken, which is equal to plus delta P upon delta T, which is equal to plus T2 minus P1 upon T2 minus T1. And here positive sign is denoting an increase in the concentration of products. Graphical representation, also we have seen concentration of reactants versus time. So this is a quick revision of what we have done in the previous lecture. And once we have revised this, because this part was included in the last lecture, I thought I should include this here also to give you a quick revision, because this is the basic, very basic of it. And if you do not get to understand this, you will not be able to understand the rest of the lecture or the rest of the chapter indeed. So I explained this in the last lecture. I spoke it in the beginning of this lecture, and now I am speaking this part in this lecture also. So I expect you to be very thorough with this part at least. So the graphical representation of the concentration of reactants versus the time, we know that the concentration of reactants decreases with the increase in time. So that is, suppose at time 0, that is when the reaction is not really started, we are taking the initial concentration of the reactant to be equal to R1. Then it decreases from this to some T2 where it will further decrease, and then at some other point of time the reactant concentration is going to further decrease, and like this the concentration of the reactant goes on decreasing with the increase in time. So this part where we have this part of the reaction where we have, sorry for the interruption, there was some technical issue. So this part of the reaction that is shown by the arrow is basically the R average. So if you see the initial concentration of the reactant is R0, then it is decreasing at time T1 to R1, and at time T2 it further decreases to R2. The time the time gap between T2 and T1 is very, very, very small. And from here, we can actually get to understand the average rate of the reaction. So our average, that is average rate of the reaction, is minus delta R upon delta T. And here it is going to be delta R will be minus of R2 minus R1 divided by T2 minus T1. So I hope the average rate concept is clear to you. Next, if we have the concentration of product versus time, at time T1, we have the concentration as P1. As time increases, the concentration increases, and this way we have the, sorry for this extra line here, this should actually be the x-axis here. I don't know what is the problem right now. Anyways, so this very small time gap, that is T2 minus T1, is going to give me our average as P2 minus P1 divided by T2 minus T1. Now the negative sign, this is an MCQ question for you. The negative sign to the rate of reaction with respect to concentration of reactants dash in the duration of the dash in duration period of reaction. That means the negative sign indicates what? Does it indicate the increase in concentration of the reactant? Then it would have been a positive sign. Concentration of the product increases, it increases, but the negative sign is not for that. The concentration of reactants decreases, or there is no change or does not change the rate of the reaction. So option C is the right answer. Next, we move on to the problems. So since we have covered majorly what the rate of reactions is concerned about, so now we are going to move on to the problems associated with the rate of reactions. Let us have a look at the question. For the reaction, that is R goes to P, the concentration of a reactant changes from 0.03 molar to 0.02 molar in 25 minutes. Okay. You have to calculate the average rate of reaction using the units of time, both in minutes as well as seconds. So remember what the formula for the average rate of reaction is. R average is equal to P2 minus P1 upon T2 minus T1. And since you have to give the rate of reaction in both minutes as well as seconds, the units of the rate of reaction are going to be accordingly changed. So I want you to solve this question first and then have a look at the solution and match your answer. Okay, let's just have a look at the solution now. R average is minus of delta R upon delta T, which is equal to minus of, since these are the reactant concentrations that are given to you, you need to take into account the minus sign here, and R2 minus R1, that is 0.02 minus 0.03 divided by 25 minutes. So that would be 4 into 10 raised to power minus 4 moles per liter per minute. And when you have to convert it into seconds, that would be the whole expression divided by 60. So that would be equal to 6.67 into 10 raised to power minus 6 moles per liter per second. The next question is, for a given reaction, C4H9Cl plus H2O giving C4H9OH plus HCl. The concentrations of butyl chloride, that is C4H9Cl, at different times given as follows. So this is the whole table that is provided to you, where you have the time and you have the concentration. Keep a note of this table, okay? The question is, you have to calculate the average rate of the reaction during the first interval when the concentration changes from 0.1 to 0.0905. The second interval when it changes from 0.0905 to 0.0820. Okay, this is what you have to calculate. So look at the table and then solve this question. After you've solved, you've got the answer. Then look at the solution and match your answer. Now let us have a look at the solution. The average rate of the reaction during the first interval, R average, will be minus delta R upon delta T, which is minus of R2 minus R1 upon T2 minus T1. So in the first interval, the concentration is changing from zero point 0.1 to 0.0905 molar. So R2 is 0.0905 molar and R1 is 0.1 molar. So our average will be equal to minus of 0.0905 minus 0.1 upon 50 minus 0 seconds. Now, since the initial time is where we are starting the reaction, that is 0 that is given to us. So T2 minus T1. So that is the data that you have to take from the table that is provided. So the answer would be 1.9 into 10 raised to power minus 4 moles per liter per second. There should be a negative sign here also that turns negative and negative positive. The second interval, when the concentration is changing from 0.0905 to 0.0820, it would be again R2 minus R1 upon this time, since it would be T3 according to the table, T3 minus T2. So 100 minus 50, the answer would be 1.7 into 10 raised to power minus 4 moles per liter per second. Now let us have a look at the next question. From the concentrations of butyl chloride at different times given below, that is using the same table, you have to determine the instantaneous rate of reaction. That is, now we are not going to determine the average rate between like a given time period from T1 to T2 and you subtract the time to get what the time taken was. No, you have to calculate instantaneous, means at suppose once the reaction has started taking place, what is going to be the rate at 600th second, and so on. So how would you do that? Again, the table remains the same. See, instantaneous reaction based question. This is the first one. So I'm going to solve it for you first. So what do we see is that it can be determined graphically by drawing a tangent at time t at 600 seconds, and it can be calculated by plotting. So whatever the concentration is given to us, we will plot it on the y-axis. We will take the time taken on the x-axis. We will draw a graph. And at whatever time period we have been asked to give the instantaneous rate, we will draw a tangent that touches the curve at that particular time period. So according to the table, see this you have to perform on a real graph paper, okay? So obviously this type of question will not be asked to you in objective type paper, but that can be asked to you in a subjective type paper. So be prepared. So we write down the time, we choose an appropriate scale for time. We choose an appropriate scale for the concentration. Now we plot a graph according to the given information. At 600th second, we draw a tangent. Okay, this is how a tangent has been drawn. This line is the tangent to this point. So this would be the instantaneous rate at 600 seconds. So it can be determined graphically by drawing a tangent at time t, and we get the slope of the tangent to give the instantaneous rate. And how do we calculate the slope? See, for any graph, not just this particular graph, wherever we want to find out the slope using a tangent, when we have drawn the tangent, the slope is equal to y2 minus y1 upon x2 minus x1. That is from one particular point on the y-axis to another particular point on the y-axis. That is higher point minus lower point divided by a higher point on the x-axis minus the lower point on the x-axis. So that would be minus y2 minus y1 upon x2 minus x1. So that would be 5.12 into 10 raised to power minus 5 moles per liter per second. Similarly, for The rest of the time periods also from the graph we can calculate, and these are the answers. Once you've calculated after drawing the graph, you can simply match your answers. And if you feel you are wrong somewhere, please check your calculations because the answers are correct here out. All you need to do is to check the calculations for the slope part. Next question is, in a reaction, there are 2 moles of the reactant A getting converted into products. The concentration of A decreases from 0.5. Remember here the stoichiometry is very, very important while determining the rate of the reaction. The concentration of A decreases from 0.5 moles per liter to 0.4 moles per liter in 10 minutes. You have to calculate the rate during this interval. So it's nothing but the average time only, average rate only that is being asked here. But there is a stoichiometry thing that we need to consider here. 2 moles of the reactants have been provided and therefore we are supposed to calculate accordingly. So let me give you the solution for this. The average rate would be minus of half into delta A upon delta T. So how do we take into account the stoichiometry before the reactant or the product? We divide the concentration by that number. So minus delta A by T remains there. We are just dividing delta A by 2. Because the total A that is involved that we are taking in the reaction, we cannot take twice of it, right? Therefore, we have to divide it by 2. So that would be half into the data that is given. So answer is 0.005 moles per liter per minute. It was a very, very easy question, but just this stoichiometry part was involved. Therefore, I had to provide you the solution first. Now, we move on to the rate of reactions where we will talk about the average rate of reaction. We have already discussed what is average rate of reaction, but now we are also bringing into account the stoichiometry as we have seen in just the last question that we have done. Now, for a reaction A giving B, the rate with respect to A is minus delta A by delta B, delta T, and rate with respect to B is plus delta B by delta T. Simple. At any instant, the rate that is measured with respect to the reactant would be rate measured with respect to the product. Therefore, rate will be equal to minus delta A by delta T equal to delta B by delta T. For a reaction in general, N1A plus N2B giving M1C plus M2D, the rate expression may be expressed as, see, I have already told you how to take into account the stoichiometry with respect to a particular reactant or product. We simply divide the concentration by that coefficient. So the rate of the reaction will be minus 1 upon N1 delta A by delta T minus, so with respect to this will be equal to minus 1 upon N2 delta B by delta T equal to plus 1 upon M1 delta C by delta T is equal to plus 1 upon M2 delta D by delta T. Very, very, very simple to understand. So let us see a question based on this. For the given equation, you have to find out the rate of reaction. PCl5 giving PCl3 plus Cl2 gas. Quickly find out the rate equation only. There is no data provided. There is nothing that you have to calculate. You just have to put in the rate equation here. So the rate will be minus delta PCl5 upon delta T equal to plus delta PCl3 upon delta T equal to plus Cl2 upon delta Cl2 upon delta T. Next question is, again you have to find the rate equation this time for this, which is again very simple, just very similar to what we have done in the previous question. So I think should not take more than a second for you to answer this. Minus delta Hg upon delta T minus delta Cl2 upon delta T plus delta HgCl2 upon delta T. Now, you have to find out the rate equation for this reaction. Now, your stoichiometry comes into picture. So, rate of reaction will be equal to minus 1 by 2 delta N2NO5 divided by delta T equal to plus 1 upon 4 delta N2 upon delta T is equal to delta O2 upon delta T. So, now if supposedly you have to find out delta O, with respect to, suppose delta N2 has been provided to you, then, or suppose you have to find out delta N2 and delta O has been provided to you. So delta NO2 will be equal to 4 times. We will take this part of the equation. So delta NO2 upon delta T will be 4 times delta O2 upon delta T. Next question. For this particular reaction, you have to give the rate equation. Again, very simple, just to take into account the stoichiometry. So, minus delta N2 upon delta T is equals to minus 1 upon 3 delta H2 upon delta T is equal to delta NH3 upon delta T. Okay? Sorry, plus half delta NH3 upon delta T. That's the right answer. Now, we will be taking into account the instantaneous reactions and the rate equations for them. So what is instantaneous reaction? The rate of the reaction at one particular instance of time, that is specific instant, is known as instantaneous rate. Very simple. So, like supposedly you have been asked to find out what the speed of the reaction at this particular time is. Okay, suppose you are driving a car and someone is sitting next to you. He says it's 12 o'clock right now. What is the speed of the car right now? He says 100 kilometers per hour. So then he would know that at particular instant of that time, that is at 12 o'clock, the speed was 100 kilometers per hour. Similarly, if I say at 600 seconds, what would be the rate of the reaction? So at that particular instant, the rate would be the instantaneous rate. So how do we calculate? Limit delta T tending to 0, delta C upon delta T. So how do we define it? The change in the concentration measured over an infinitesimal time span is known as instantaneous rate. Infinitesimally small means when delta T tends to 0. It's not equal to 0, it tends to 0. Then at that point of time, we will have the calculation for the rate of the reaction. For example, PCl5 giving PCl3 plus Cl2, the rate we know is given by minus, not delta here, okay, it's dPCl5 upon dt. Why d by dt? Because we are talking about very short span of time and a very small amount of difference, okay. So when we talk about large differences, we use delta triangle. But when we talk about very small differences, we talk in terms of d by dt. That is the differential form of it, which will be equal to dPCl3 upon dt equal to dCl2 upon dt. So delta is used for larger change, that is average rate, and d is used for infinitesimally small change, that is instantaneous rate. Let us look at another example. The rate equation for this would be, now you write down the rate equation and then match it with what I am going to provide you as the solution for it. Okay, you must have written by now. So minus half dN2 by dt, dN2O5 by dt equal to plus 1 by 4 dNO2 by dt is equal to dO2 by dt. Now, how do we represent instantaneous rate in a graphical form? So again, the concentration of reactant versus time. I'm really sorry for this x-axis going again in the vertical position. I don't know what is wrong with the x-axis here. It's getting notorious. Anyways, so if we take the concentration of the reactant on the y-axis and the time on the x-axis, we start with R naught, that is the initial concentration of the reactant. R naught simply represents the concentration at time 0 when the reaction is not really started. So what is the initial amount of reactant that we are taking? With the increase in time, that is as time goes from t is equals to 0 to t is equals to t1, it becomes R1, then to t2 it becomes R2. So at, we know that R average is minus delta R upon delta T, that is minus of R2 minus R1 upon T2 minus T1. But how do we calculate the instantaneous rate? The instantaneous rate would be simply the tangent which is drawn at one particular instant of time that is asked to us. Okay, this is how we draw the tangent. And for this point, we have a corresponding value, say y2, and we have x2. For this point, we have y1 and we have x1. So y2 minus y1 upon x2 minus x1 will give me the slope. So our instantaneous would be limit delta t tends to 0 minus delta r upon delta t, which is minus dr by dt. So rate will be the slope of the tangent. Let us see a few MCQs here. The rate of reaction for N2 plus 3H2 giving 2NH3 would be. These are the options. So quickly tell me, see, you have to have a look at three things here. The products have got a negative sign with them. Sorry, the reactants have got a negative sign with them and the products have got a positive sign with them. The stoichiometry is written correctly in front of every particular reactant and product involved. And thirdly, the stoichiometry comes in the denominator, not in the numerator. So, minus dN2 by dt minus 1 by 3 dH2 by dt plus 1 by 2 dNH3 by dt. Option A is the right answer. Next question is, for half x2 plus y2 giving xy2, the rate can be expressed as. So this half is where you have the coefficient of x2. So since we know that it's concentration divided by the coefficient, so concentration of x divided by 1 by 2. So this time 2 comes in the numerator. So the option B would be the right answer. Next question, for this reaction, the rate of the reaction is. So it's like we know that any of the reactant or any of the product can give me the rate of the reaction. I just have to see that what has been mentioned correctly here. So in terms of N2O5, if I see, there should be a negative sign, which is not there in any of the options. So let us leave options A and B. Then when I talk of in terms of NO2, there should be a positive sign, which is there in option C and D. But the coefficient should also be taken into account. That should be 1 by 4. So option C is the right answer here. This is the explanation, which I don't think I need to repeat. The rate of a reaction at a particular instant is called, clear from the question itself, particular instant. So instantaneous reaction rate. Last question is, instantaneous rate can be found by calculation, experiment, can't be found, graphically. So we have seen that instantaneous rate can be found from the slope of the graph. So graphically, option D is the right answer. So this is all about the rates of reactions. We have practiced a lot of questions and numericals based on rate of reaction. I would still suggest you to practice more questions and be very thorough with the numericals, because in the exam you tend to get numericals mostly from this chapter. Okay, you can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app for continuous learning through your smartphones. Keep learning with First Online University, a team of millions of learners and educators worldwide.